Welcome back to this tutorial about longitudes and latitudes. In the previous tutorial, we have looked at latitudes and longitudes in quite a broader length of analogies. Today, we are going to look at it in a mathematical point and theoretical points as we now venture into calculations to be able to understand what we have this time. Before that, let's bow down for a word of prayer. Lord, make longitudes and latitudes topic in mathematics clear to my student that I'm able to understand it clearly. Just may pray. Amen. Sorry for that mispronunciation error. I come from some slopes somewhere, whereas you come from some plains. Now, basically today, we are now going to dig deeper. After understanding the concept between longitudes and latitudes, we want now to deeply venture into the Earth, how it looks like. That's just a diagrammatical example of how the Earth looks like. But now, I want us to understand something. How do we name positions on the surface of the Earth? We have norths and south, eastings and northings and southings, eastings and wests. I don't know if it's called westings, though in high school you were saying northings, eastings. I'm not sure of southings and westings. Confirm that. This is mathematics. Notice, as the longitudes run from north to south, you cannot name them north to south because it will just be a single line. So to name them, I'll name them from east, west, like that. So longitudes are measured as eastings or are measured as easts or wests, depending with where you are with respect to the prime meridian. So let me just position them the way they should. If I assume that this is my zero, my prime meridian or Greenwich meridian, all the longitudes that will be on the right side when you face the Earth, assuming that I'm in space and I'm facing the Earth the way it is. Let me recollect my oranges here so that you may get a practical analogy. Having this, you'll notice that my longitudes, assuming that this is the Greenwich meridian, all the longitudes that will be on the right side of that Greenwich meridian will be east. I'll term them as east. But how many want east? I'll term them as, for example, 0 degrees, 1 degree to the east, 50 degrees to the east, 100 degrees to the east. Or if it's to the left side, these particular longitudes, I'll term them as, for example, 50 degrees to the east, 49 degrees to the west, 106 degrees to the west, and all the other things. What of latitudes? Notice latitudes, they run from east to west, but to clearly distinct them, I'll run from north to south. So I'll name them as, this is 5 degrees to the north, this number of degrees to the north, because it will be the northern hemisphere and the southern hemisphere. That is now easier to understand. So it will be these degrees to the south or this number of degrees to the west. So basically, in my analogy, I want us to use alpha and theta. So if I have a point on the surface of the Earth, having that, let's say this is the 0 degrees. Then we have this as, let's say, 15 degrees to the east. And this is, let's say, 30 degrees to the north. I'll find that this point here, with respect to the center of the Earth, this point here, there is a way in which we are going to use to be able to give the number of degrees, but for now I've just stated it the way it should. We'll also explain why we are saying this 30 degrees and 15 degrees. So how do we name these particular points? in naming them, will always be, we know that, let me just start from the planes that we know how to draw graphs. We usually start with the x coordinate, then the y coordinate, right? I believe you remember that. If you have that graph of that line of yours, I'll say this one is this here and that, x coordinate and the y coordinate. So basically the same analogy is also used. It will be the x coordinate, assuming that this is the x coordinate, and the y coordinates. The y coordinates will be the longitudes, and the x coordinates the latitudes. So I'll begin with, for example, theta degrees to the north or to the south, and then alpha degrees to the east or to the west. It is usually latitudes, longitudes. So what does it mean? This point A, if I want to state it, it will be 30 degrees to the north and 15 degrees to the east. If I have another point here, let me say this one here is 8 degrees to the south, and this one here is 49 degrees to the west. How will I state that? Point B. Point B, you'll find that point B, it will be 8 degrees to the south and 49 degrees to the west. Try this one. Point C. So this is the 0 degree longitude, that's the prime meridian, and this is the latitude, 0 degrees, the equator. So that will be 0 degrees, and basically 0 degrees will just be 0 degrees. You will not have north or south. So basically those are various examples. I want you to try this. If I have the Earth, this is 0 degrees, assuming that this one is 57 degrees to the east, and this one here is 31 degrees to the west. I have my latitude equator. This one here is, let me say, 7 degrees to the north. This one here is 86 degrees to the south. I wanted to state the following points. State the position of the following towns. We have towns A. So we have the point A. Try again point B here. Yeah, basically you can try out those 2 points. So this one is not similar to this, so try working out on that. So after stating that, you shall work on that. That's just to exercise. I want us to go to the next thing. Find that 2 points on the Earth's surface have a distance between them measured along the circle on which the 2 points lie. Notice, if I have, for example, if I decide to add another point here, maybe I can have you add that point C. Tracking out also point C and point D. I've just seen the need. So we have point C here and point D. Point A, B, C, D will set all the 4 points. Now, if I have point A and point C, so assuming that here is where the center of the Earth is, and that's where all the mean positions are taken from, I'll end up with an arc in this manner that will have a particular angle in between. So notice I'll be calculating distance. If you are told, for example, calculate distance along A and C, it will be an arc length. Shall also look at the definitions of how to get those particular distances. Or if it's A and D, there shall also be a center that it will be calculated from. So basically what we mean, there's an arc, there's a circle that you will calculate the distance from. If it's, for example, this case, find that it will be in this manner, and I'll get this. But it becomes a special case if you have A and D, because it has to be along a plane in which those 2 points are lying. These 2 points lie on different longitudes but the same latitude, so the plane that it will lie, it will be on this latitude. We shall also explain. This is latitudes, majorly the usual is like special cases that we shall also explain with time. So for them, their center is here, but for longitudes, all of them, they have a common point whereby you measure them from. So points can lie on a great circle or a small circle. Now let us explain what a great circle is. A great circle is a circle whose radius is equal to the radius of the Earth. Notice that all longitudes, they have an equal radius. All are equal, so meaning they are all called great circles. The same thing applies to the equator. The equator is the only great circle among the latitudes because it's also equal to the radius of the Earth. What of a small circle? A small circle is a circle whose radius is less than the radius of the Earth, meaning any latitude above the 0 degree mark, it will have less radius than the Earth. So for example, if it's 1 degrees to the north, 50 degrees to the north, 1 degree to the south, 49 degrees to the south, 89 degrees to the south, whatever it is, all of them will be termed as small circles. So if I have my capital R and a small r, this is simply a great circle, the radius of the Earth, and this is the radius of a small circle. For example, in this one, you'll notice that it has a small radius. We shall see on how that is calculated. Here we'll have a small circle. So we shall dive deeply into how to be able to define the great circles and small circles in detail in our following next tutorial. May God bless you.